Jai Hind and welcome viewers to a very special new session, a new episode from our platform. And this one is where we are showcasing inventions and innovations. We have with us Mr. Adess Singh. He's a physicist and inventor with a record of accomplishments in developing and patenting technologies in energy, security, environment, automotive, and health sectors, among others. He has an insatiable curiosity and passion for developing promising solutions to issues of global concerns, having which have led to pioneering work done independently or with major organizations. We also have with us Mr. Rajandeep Singh Tiwana. He's a technocrat and entrepreneur and an exemplary record of 30 years he has in founding and managing diverse enterprises in manufacturing, civil construction and garment, export sector, and also he has an inherent passion for technology and innovation, which is which has led him to develop number of solutions in areas of security, environment, and automotive sectors. So, my first question today's interaction is to you, Mr. Adess Singh, and that is
See,
this CentriAirFlow, which you have invented. It looks like a simple device, but and in the automotive industry, which has been looking at these innovations over the years, you stuck upon this method of doing this. In your opinion, how is it that similar products were not developed earlier by the industry? Others, please.
yeah. Thank you, Jasted for having us on this forum, and which is consists of very, very accomplished people who are in the field of engineering, engines, maintenance, and so on and so forth, spread word over. We are very happy to be here. And as for your question, sir, I'll tell you that, something for all inventors. And in fact, while speaking to you, I could gauge that you too, at some time, were involved in some invention. I'm not going to ask you what those were. Okay. There is one fatal flaw which an inventor or a studious person or researcher makes in the very first stages, that he does on his idea, he does a literature survey. That is the best way of killing a good idea. Because it's funny to say this, because the literature is composed of things which people made for themselves, for a particular application or for a particular objective. It cannot and shall not have the objectives that you have in mind. So, if you go into literature survey of anything, nobody will make anything at all. So, sab to pehle to this has to be shut. You keep the literature survey for a different time, maybe at the time of filing a patent or something. Very often, very good ideas get killed in the nascent stage because of this. And that is exactly what happened to CentriAirFlow. This starts from a very simple thing. I'd gone to drop my son to the school on my motorcycle. I was on the way back at a red signal. My motorcycle stopped behind a three-wheeler, and I was hemmed in by traffic on all sides. And the three-wheeler was spewing out black, dirty smoke. It was impossible to breathe, but I could do nothing. But only thing that happened, that my anger went through the roof. And by the time the light changed, we had sort of solved the problem. I said, centrifuge the damn thing. And then while crossing the light, I said, fir ye pani ke chite manni. I said, first pass it through water. While crossing the light, I said, if gande chite marega pani ke. Then I said, centrifuge it. And then I sat down on the phone, talked to Rajan, put things together. And so this thing developed. And when we made it, and we started working on it. We did not even have a vehicle on which to test. I took the device to the engineering college in Punjab University and I said कि यार ये सामान है सर मेरे पास, आपके पास इंजन है, थोड़ा बांध के चला लो. कहने मेरे स्टूडेंट्स का तो प्रोजेक्ट करवा दे. मैं कहा sure, I'll do it. We did it and it came out great. So from there it started and here it is now. And all the time that I see why the industry did not make it was because they were constantly referring to published literature. Usme, this thing is not more than 10-15% efficient on any count because it uses different methods of achieving that thing. The people who did that literature or wrote that literature were not looking for the things we are looking. So that is how this thing took this thing was sort of, hidden from view. And other than the facts of, I have been saying this, Rajan, I and Rajan both are gifted with the owl, vision. Usko andhere mein nazar aata hai, ullu ko. So he can see in the dark and yeah, so that's why the industry never got to CentriAirFlow, which is a 2.5 pipe innovation, and it does great things.
Thank you for that, Adess. And as I see it, as CentriFlow, gets accepted in the aftermarket segment and maybe also with the OEMs, what additional benefits other than these? You are saying that the benefits which you have mentioned, are you expecting, and which will make it even more popular? And maybe a start point, seeing your example for other innovators, as well as innovators within the industry. Adess, please.
So what CentriAirFlow does fundamentally is it takes the exhaust gas and uses its high speed, okay, to cause a very high rate of spin. What this high rate of spin does is it separates out the denser matter in exhaust gas or flue gas. Denser matter consists of particulate matter, carbon dioxide, NOx. These are dense gases. They separate out. And once they separate out, it is sent offline. It is sent in a different direction away from the normal flow of the exhaust gas. Now, once you've separated these things out, the amount of gas needed even to treat NOx or CO is reduced in volume. And this thing is even more critical in the flue gas large furnaces thing. Okay, the furnace may be very large, the volumes of flue gas can be gigantic. Therefore, the treatment of the flue gas plant is also gigantic in size. Because all gas, mostly consisting of nitrogen, is passed through the treatment plant. Whereas with CentriAirFlow and its modification, you can reduce that volume to about 20%, even in a big furnace. Definitely so in a vehicle. So once you've got your NOx and your CO, sorry, not CO, NOx and carbon dioxide onto one side, you can treat it with much less cost, smaller catalytic converters, less costing. So those are things wherein industry research will be coming in on the basis of CentriAirFlow. CentriAirFlow is the base. And that shall really, boost the applicability usage of internal combustion engines. As it is, CentriAirFlow will give you a 20% plus fuel economy advantage. Over and above that, you get the cost benefit of treating NOx in a way. Yeah.
Thank you very much for that, Adess. Now, Rajan, over to you. My first question to you is that CentriAirFlow is obviously a huge, possibly a huge market attraction, with the benefits which I just mentioned. And it seems to be a win-win solution. So, as a user, owner, and the industry, as far as the environment is concerned, everybody is going to gain. So, what, in your opinion, is needed for it to get into the market? Rajan, please.
Thank you for inviting me. To get to that question, I'll go into the background a little bit. So you see, we've been working on this product for the last more than 12, 14 years. And we've been refining it. As a matter of fact, this is one of the products that gave us the national award also. And that was in 2014. So we've been at it for a very long time, and we've been fine tuning it, and we've already spent huge amounts of money. If I may be candid, we've spent nearly 10 crores already on it. And but that is because of the conviction that we have that this is something that is huge, not only in the commercial market, but also it has a huge social impact, which is what our initial objective was. So what um, during that development stage, what has happened is that we have gone through various iterations of this product. We have gone through what is called loosely called beta testing, because beta testing is a very formal activity. But we have gone through installing it on about 18 odd heavy duty vehicles which have run more than 1 lakh kilometers each. And we had installed GPS, etc., on them so as to get a real time data of output, which means power to consumption ratio, as well as the smoke output parameters to see how much pollution are we actually taking care of. Now, those are very, very encouraging. We have, again, to be candid, we have averaged from 22% to up to 40% in fuel saving itself. Now, if I were to tell you in reference, I mean, how to actually, what does this mean in real terms? About 12 years ago, BMW spent approximately $1 billion to get to 3% fuel efficiency. So look at what we are doing, and this is, but you see now, for that we've spent a lot of money and we've spent a lot of inputs. Today, what we need to do to actually get people interested and get this rolling and get this into the domain where it is most effective is we need to get a strong marketing team, we need to get a strong lobbying team, and we need to set up a proper laboratory which will do our iterations, which will do our tests. Although we've got our tests done, our validations have been done by international agencies, our validations have been done by ICAT. So all those are there. But on a day-to-day basis, smoke tests as well as fuel efficiency tests are necessary under different loads. So you see, what we need is to set up a laboratory which can do the fundamentals of this before handing it over to actual experts to do a beta test, to do a market, it's basically called a market litmus test. So before it goes there, it requires a lot of inputs from us, and that requires a lot of funding. Even to license it, let's not look at manufacturing our product. Let's look at only licensing our product, and this will be billions of dollars commercially. And of course, the social impact is incalculable. And the other thing is, for example, what has happened is NGT has banned 10-year diesel vehicles, 15-year petrol vehicles on the basis that they are polluting. Our product will take you from a Bharat stage. These are our tests done by AVL, done by ICAT. These are huge validating laboratories of the country and international. AVL is the biggest private international validating agency. And our test, we have those results where it is very clear that a Bharat stage 3 vehicle, which is what we were testing on, will give you results which they expect from a Bharat stage 6 vehicle. And even better. And therefore, all these vehicles that are being thrown away need not be. And there are various other advantages to this. You see, actually, fossil fuel has been demonized. We can bring it back into being green fuel. And it is a green fuel. It is because of the misuse that it is not green anymore. But for that matter, neither are batteries. But we won't go there. But today we can do all that.
Thank you for that, giving the picture of how much effort has gone into making it and how you're looking at possibly future taking it forward. So my next question to you is, how dependable is this CentriAirFlow which you have invented, and how can it be, have dependability equal to the presently used systems, and also how long will a CentriAirFlow piece last? Rajan, please.
Okay. So I'll first take you to what happens today. In this milli to clean air, clean pollutants sort of story, what the industry has been doing is installing more and more restrictive filtration systems, maybe chemical, maybe physical, to make sure that whatever is coming out of the engine exhaust is processed within the vehicle in real time, and very little of what is actually coming out the engine goes out the tailpipe. However, there is a trick here. What is happening is, what they are installing is something called a DPF in a diesel engine, and similarly a gasoline filtrate. So what DPF does is that it entraps the gases as they are coming out of the engine. It will entrap chemically as well as physically. It will entrap the particulate. Then there are cat converters which will convert, let's say, toxic gases into more friendly gases. All these are filtration processes. All these are restrictive processes, with the result that every vehicle that could have given you 10 kilometers to a liter is not going to give you more than 6 or 8 kilometers to a liter. Now, the other problem with DPF is, what DPF does is that it entraps particulate matter. Now you have to actually burn off that particulate matter from within the DPF so that it can entrap more. Once you are doing that, it is called regeneration. So every vehicle these days automatically, earlier it used to be that they have to regenerate, the light would come on in the dashboard. Now regeneration basically means that huge amount of diesel is pumped into the DPF. It is given a huge amount of heat, with the result that the particulate that was size X is reduced to size X by 100, and then again pumped out the tailpipe. So now what is happening is that the particulate which was less effective as a carcinogen has now become very effective, because as it grows smaller, it is never going to settle down with gravity. It is always up in the air with upward flow of winds. It will go into the cloud. Now it will travel hundreds of miles and it will rain everywhere. So ultimately, they also know that DPF is not a solution. DPF was a stopgap arrangement, it was a band aid, but they don't have anything else. And they have now spent millions of dollars into DPF, so it's not going to be easy to displace it. But the truth is, DPF is ultimately not solving the problem for which it was manufactured. CentriAirFlow does all that at maybe 1,000th the cost. DPF is not cheap. And DPF has to be replaced from 40,000 to 80,000 kilometers in a commercial vehicle. Whereas CentriAirFlow will outlast the life of that vehicle and the life of the next vehicle, because it has no working parts. All it needs is normal servicing process, which is to be done when the vehicle goes for oil change, filter change, etc. There is a simple process which will also reservice the CAF at a cost of not more than 5,000 rupees, and you have a new piece again. Now, as against 70,000 rupees, you're spending 5,000 rupees, and forever it is not going to have any problems. You see, so DPF, the DPF against CAF, there is no comparison.
Thank you for that. And in fact, now, viewers, we are lucky that Mr. Adess Singh has a presentation for us. So,
Sure.
over to Mr. Adess Singh for showing us their product in more detail. You could share your presentation.
Yeah. So despite its simplicity that you said about earlier, it is a disruptive breakthrough. And CentriAirFlow, or CAF for short, removes particulates from engine exhaust while reducing the back pressure. This is the crux of the whole situation. And the back pressure is removed, the engine efficiency goes up, so the fuel economy gets better because the voiding of the combustion chamber gets better. Okay. And this technology is at a technology readiness level of 8 plus, well, 9 is commercialization. So we are at the brink of the commercialization. And I'll go to the next slide. And I'll tell you one little thing which will help us understand fuel consumption better. Suppose somebody is used to doing a little jogging, and we say, okay, please jog a kilometer and then stop there. And he gets his breath back and he gets everything all right. And then we put two masks on the person's face and we ask that person to jog back that 1 kilometer. He will stop very early because he can neither breathe out and therefore neither breathe in. And the heart-lung machine, heart-lung ensemble is like a engine. So anything that is restrictive will cause fuel increase. Anything that is giving freedom will cause better fuel economy. So resistive methods like the DPF, which Rajan had explained, they increase the back pressure, decrease engine power because the voiding is simply not done. And then the collected soot is burnt inside the DPF. Therefore, smaller particles are released. Although the industry says, no, no, we burn at 920 degrees centigrade. So it's all carbon dioxide. It is not particulate, which is neither here nor there. And more importantly, it has high maintenance and replacement costs. These days, you will be hearing of theft of exhaust systems. People go under, have a electric saw, they cut off the exhaust system. And because what is inside these catalytic converters and the DPF is a lot of money for those who've done the theft. So this is where we are standing as of just now. CentriAirFlow, what it does. Okay. So what do we do? Most of the time, the industry tries to kill the speed of the exhaust gas so that the sound is less, so that this, that, and the other. We use the speed of the exhaust gas to cause a high speed circulation of high RPM circulation of the exhaust gas. It is extremely high rate because it's a total free vortex circulation. And that causes the gravitational force sufficient to separate the finest, even 1 micron is removed from the exhaust gas and sent elsewhere. Because we are voiding the cylinder better and we are having better consumption, so the carbon monoxide level drops greatly. It has been seen in the tests. Because we consume less fuel, we reduce the carbon footprint. And the tests have shown that NOx also comes down to a very high degree as compared to the normal exhaust system that is there. Further, sir, the universality of CentriAirFlow is absolutely wonderful. The engine can be of any type, means any fuel that use internal combustion engine, or it could be of any vintage. CentriAirFlow will simply fit and perform from the time it is fitted and is ready to deploy. Further, those who get interested into the commercial aspects, this is patented in India, USA, and Europe. So there is the commercial aspects are taken care of nicely. Method is we reduce the muffler, we remove the resonator, we put the CentriAirFlow and take the vehicle out. That's all. What does the CentriAirFlow look from the inside? This is how it approximately looks from the outside. How does it look from the inside is something like this. And I'll take you quickly through this. Exhaust gas from the engine enters port 1 or 2 or maybe 1, and it begins to spin because these are tangential entries into a cylindrical chamber. And on the axial surface of the cylindrical chamber, there are ports and other methods. of taking the denser exhaust gas into this entrapment chamber. This entrapment chamber pressure goes a little high, whereas at the center of the vortex, everybody knows who's even studied geography, there is at center of the cyclone, there is low pressure. So from the high pressure, some gases come into the low pressure area and go in for a second spin, making sure that no particulates go actually out. The lighter gases move actually out. That's CentriAirFlow in simple terms. On the right side, there are some gas densities that are mentioned here. I'm going to take that up in slightly after a few slides more. Okay, so this was one of the earliest tests in ICAT, I think 2000, late 2014 or 15. So you see the gas entry here. You see particulates being separated in the entrapment chamber. Those days we used to use a filter in the entrapment chamber, offline. And then the clean gases go out. And the G forces are phenomenal. They are very high because if you do the calculations, they will come to about tens of thousands of G. Whereas particulates can separate even in 50 or 100 G. And if you want to know what size particulate can CentriAirFlow remove, this is an electron microscope picture of that filter. So this white bar you see where I'm putting my cursor, that represents 1 micron length. You can see that the particles much smaller than 1 micron have been individually separated, and then they are agglomerating inside and becoming large. So the fact is that CentriAirFlow removes even the finest of particulate matters without filtration. That's the important part. And while causing a drop in the back pressure. So we have a Safari, 2006 Safari, and we used to run tests on that. This is an earlier test. A white paper used to be put in the inside of the tailpipe. This is what happens in 50 kilometers of driving on the left side. And with CentriAirFlow, even 150 kilometers of driving, it remains mostly white. The particulates are all entrapped inside the CentriAirFlow. This is what it looks like now. And it breaks the limiting barrier of the present technology. You see, presently, the industry is in a pincer movement. The government tells them particulates also should drop and NOx should also drop. That is very, very difficult for them. And the fuel consumption. The minute you try to filter particulates, your fuel consumption will go up. Or you try to remove NOx by putting another process in between, in inline process, again, the fuel consumption will go up. So there is a griddle lock. There's a pincer movement under which it's a negative spiral. So the industry is freed from that negative spiral. You give it speed, you will remove particulate matter. Because of ease of the flow of the gas, you will have fuel economy, substantial fuel economy, 20 plus PSI. And that is there in the test it has shown. So these are the benefits that come from using the CAF, and no expensive exhaust systems as of present. It's lakhs of rupees that go into a DPF and various other technology that goes in. In fact, it becomes a temptation for thieves to cut it and sell it in the gray market. Since we got the National Award 2014, we've been places. We did the initial proof of testing claims 2016. And in 2018, we were at the Clean Tech Open selection. We were selected at Los Angeles for the finals. Road tests have been done over 1 lakh kilometers. Intellectual properties exist, as I said earlier, in India, in the US, and in Europe. And field validation testing also is complete. So we have got a product which is there ready to fire, and a few more additions here and there, plus of course the marketing costs, and it should be a good business proposition. And also, as I said, a win-win. It is good for the owner, it is good for the industry, it is good for the environment also. This is a picture from one of the field test that was done somewhere in Chennai. There you see the CAF. It's much smaller in size than the normal long muffler. It gave a fuel efficiency of about 20% saving. And now we come to the other major use of CentriAirFlow technology, slightly modified, but maybe. When we were describing this to the government, we were surprised to see the response from the Ministry of Power. Anyway, after that, COVID hit, and this effort just got lost. We are already at this place with CentriAirFlow. We have done all this. And field trials have been done extensively, as Rajan also told us, on commercial vehicles, which are the major users of diesel and fuel. And if the government understands this clearly, a 20% plus saving on fuel is a huge, huge saving of the national wealth. So with that, I'll bring a close to this presentation.
Hey, that was very impressive, to say the least, and his brilliance, genius, and the amount of work which has gone in is quite obvious to anybody. Viewers, with that, it's come to time for me to thank both Mr. Adess Singh and Mr. Rajan Tiwana for joining us today and sharing with us this invention which they have made. On our platform, we are always looking forward to giving a place for Indian innovators to talk about what they're doing, because it fits in very well with the national mission for Atmanirbharta, and it will really be a day when we can do a lot of technology within house and use in our industry, and in fact export it outside. That will really be a great national achievement and an asset. So I believe that inventors and innovators, Indian inventors and innovators, are a big source for the increasing the national impact globally. And I thank you viewers for joining us, and thank once again, Mr. Adess Singh and Mr. Rajan Tiwana. And with that, we bring this particular episode to a close. We hope to bring more such episodes for you. Jai Hind.